everyone. We are starting the last session today, and the first speaker is Navid Shahdi from Digikala, which is an Iranian company and stands for digital goods. It's a very large e-commerce company. I actually encourage everyone to look up the story, how the company was founded. It's a good story. And without further ado, Navid.
Okay. Hello, everyone. My name is Navid, and I'm coming from the 80 million neighboring country. And today I'm going to be talking. Open the presentation. Today I'm going to be talking about Digikala, and first of all, I'll give you a very quick overview. Let me just open this. First of all, just give you some overview about myself, about the company, and then we're going to talk about our big data platform as we go on. Before I start, I wanted to thank the organizers for this opportunity. I think I'm the only one from Iran, so hopefully next year we're gonna be having more people from Iran. So yeah, I really appreciate the opportunity to present this here. Just to give you an overview about myself, you can see I'm a generalist. I did my undergrad in Iran and I left for Canada and States. Worked briefly and lived briefly in South Africa, and after 15 years I went back to Iran. These are the fields that I'm working in: medical robotics, worked at Stanford, mining robotics in South Africa, mobile robotics, space robotics, did some projects with NASA, started up a company in precision ag in Canada, was working at Facebook, computer vision, virtual and augmented reality, and most recently I've been working in AI and big data distributed computing. And I'm also very interested in philosophy and anything around that. Do we have free will? What is singularity and superintelligence? Machine language and reproduction. And I've also done some generative art. If you're interested in those topics, very happy to chat about them after. Just to give you an overview on Digikala. Digikala is the largest e-commerce platform in Iran and the Middle East. We have over 30 million unique monthly visitors and 150,000 sellers on the platform with over 7 million products. And to just give you a perspective, we are an 8,000 people company with 400 engineering team and 35 plus AI and big data team, which I'm actually heading. Okay, I don't think we need this, but just to make sure, the future is big data and AI. As you can see, the projections are showing that in 2037, deep learning and AI is going to be even bigger than the internet. So we will see, but so far we are on the right track. So just to give you an overview of what we do at Digikala, we actually do basically 3 types of products. The first type, we call them discovery product, which basically helps you find whatever you're looking for in as few clicks as possible. So imagine you're going into a store and you want to find something, and there are 7 million products in that store, so you need to quickly find what you're looking for. And also, after you found, so basically we've done search from the scratch. Also, recommendation systems, basically what you're looking for, what are the related items, what are the items that are bought together very frequently, and also last part is, and sorry for it, it's in Farsi. But yeah, and the last one is personalization. So basically understanding what is your interest, what are you looking for, and try to predict what you're looking for. So for example, if you're trying to predict if you have a kid, and what's the probability of you doing a purchase next week, what is the probability of you churning and basically leaving the platform. So we can use all of this prediction to give you the best service and keep you as engaged as possible. So that was basically the B2C part of of our work, which is basically interfacing with tens of millions of people every day. And we also have the non-discovery products, which is basically more of B2B part of what we do. And so again, it's in Farsi, but on the left you will see those are basically comments that people put on the products, and on the right is some promotions. So we also do a lot of demand predictions, promotion predictions, do a lot of text and image understanding on all the content that is being added to the website. So for example, currently we're doing completely autonomous moderation of comments. I think we have 50K comments a day, and we used to have like a team of, I don't know, 20, 30 people doing this, and currently we're doing it with AI. Also intent and sentiment analysis, and everything is done in Farsi, so we have got basically all the pre-trained networks, and usually what we do is that we add our own data to it. Also, we have a massive operations. We are moving about 1 million product a day. So we also do a lot of optimization using AI in basically our operations, how to stow, how to pick. It's pretty much very similar to what Amazon does in their warehouses. How to basically give different packages to different people to send it to people's houses. And yeah, so just an overview of the products that we have, and again, most of them, because of the sanctions, we have to do it ourselves. So we have search recommendation system and personalization. We do pricing, spatiotemporal demand prediction, meaning try to predict what is the demand is going to be both in different locations and in different times. We actually have predictions up to a month or two. We have fraud detection algorithms. We try to basically do predictions of promotions, content, image and text understanding, and we do like insights for the sellers. We also support ads, so we have our own ad network on top of our e-commerce platform, and also marketing automation, operations, and also scaling and as a service. So I'm trying to keep my talk as high level as possible, but if in any of these specific things you have any specific question, more than welcome to ask, and we can dig deeper. The other area that we are working on heavily is our big data platform. So you can imagine with such a huge amount of users that we have, we are receiving a lot of data, and we have two types of data, which one type, we call it like the behavioral data, which is basically clicks, visits, and that is in the order of, I'd say like 10 to 50K a minute, and a second, sorry. And then we have our transactional data, which is purchases. And so we want a platform, I'm going to talk about the platform in more depth, but we want a platform that can be able to ingest all of this information. Basically we have different interfaces with the user. So we have our web interface, our app interface, our web app interface. So we want to make sure to collect all of this data in a centralized location, and we can store it in a data lake. And also we can do batch processing on top of this information that we have received. So we can analyze, take insights out, and then we can use the basically outputs to basically use it in search, in recommendation systems, in, let's say, pricing, in everything that I just mentioned. Basically it sits on top of this platform. So these are a few tools that we used to use. Still we use a few of them. I don't know how many of you are basically familiar with big data tools. Can you actually ask with a show of hands how many people are familiar with big data tools here? Okay, oh, that's pretty good. So yeah, we actually used to use a Cloudera platform previously, and then we started to move a bit towards more like open source platforms like for Spark, Kafka, and our basically main database was used to be the Kudu database, and of course Redis, mainly for caching and real-time applications. And then we had Jenkins mainly for our CI/CD, and Airflow for pipeline management. And then we also had Droid for fast analytics. We use Superset Hue in Apache Atlas. So these are kind of more of our previous version of our platform. So what were the challenges that we had? I think this is also not very specific to Digikala, but any big company that is generating massive amount of data has these kind of challenges. So the first one is, which is also happening in Digikala, is data tends to basically silo in different locations. So you have transactional data in your MySQL databases. You have behavioral data, unstructured data sitting somewhere in your data lake. You have marketing is collecting its own data, ad is collecting its own data. So the challenge is going to be, you're going to have all these different types of data sitting in different places. And the main insight actually comes when you mix them. That's where the main, basically, data value added is happening, where you can actually mix these and then basically try to understand the people, the users, trying to understand the content, and try to give them tailored solutions. So, for example, based on the content, the product, you want to give an ad. Or based on the user who's using, you want to predict what they are looking for. So you need to understand them, you need to have an understanding of your users based on the interactions, which is both transactional and non-transactional. And if you are in big data business, you know that you need to know a lot of tools. You need to know how to maintain them, how to update and upgrade them. You need like broad skill sets. So in our team, like we have like 2-3 people that they know everything, and if they leave, you're gonna be in big trouble. So you need people who are like very good in data engineering, in big data engineering. They know platforms, they know pipelines, they know how to manage pipelines if something happens to them. And if you want to have your data scientists, your business analysts, marketing people use that, you're going to go through the data engineers. So that is the main problem. And as I said, it does not support like the older big data platforms. They don't support transactional data. So what are the, and basically this, what it does is it's going to stop your company or whatever research or any entity that is using big data in scaling. When I say horizontal and vertical, I mean horizontal meaning you want to have different applications. So for example, we want demand prediction, we want pricing, we want fraud, you want a feature store for your AI algorithms. So you want to add these, you want like BI, you want business intelligence, you want all these different things. They're all deep new verticals. So anything that you want to add is going to be taking a lot of time because you have to go through your data engineers. You have to ask them to provide you and build you the pipelines so you can use it. And what it does, it actually brings the data utilization of your big data down. So for example, in big companies, so I don't have an exact benchmark on this, but what I've seen around is in bigger companies, the utilization is around like less than 10 or even less than 5% because you have a massive amount of data and there is no platform to use that to generate basically insight and generate predictions based on that. And also, the more the system grows, the utilization is going to go down, and you're going to be very basically focusing on a few things because you can't do everything. The other problem is with most of the older big data platforms is that it's not scalable on the cloud. So you have to do it either on-premise, or just using a mixed solution. And basically, all of these together, it will limit the potential of getting data value added and insights out of your data. So how many of these issues have you encountered for the people who have been in the big data industry? I want to see if you actually relate to this. Okay, yeah, at the end I'll try to see if we can have a quick chat about this and the question and answer. But yeah, so the main thing is having a platform that people can use and not only data engineers can use. So it is basically some sort of a liberation for big data. So the solution that we are working on, and as I said, we are doing some of that from scratch, plus some open source libraries. It is the solution that has currently started. So they are pioneers of this. There are people who started Spark and basically the open source tools for distributed computing and distributed storage. And they have started this company called Databricks. I don't know how many people know Databricks here? Okay. So they have started, actually the CEO is Iranian, just to brag. So yeah, they are actually coming out of UC Berkeley, and so they have pioneered this cloud-based big data platform, which is kind of, these are the points that we are taking from that, and we are actually kind of following the same path. These are the things that I really like about. First of all, is state of the art, and as you know, in big data, like things changes, and you need to know all these tools. So it is very important to make sure that you are in front of the wave. Otherwise, in a year, you're going to be obsolete, and you need to keep changing your platform. It is simple, it's scalable, and it's modular. So the other thing that I really like about this platform that we are actually working on, it is modular. So for example, actually I'm gonna maybe move a bit further and then come back. So this is the high level of the platform. So we have the first layer is the ingestion layer, as I talked about. So we can have all of these different data coming in from different sources. We have the data or behavioral events, which are unstructured, like clicks, visits. You have the business events, purchases, which is structured. So the difference is in the unstructured event or the data events, if you miss a few clicks, it's not a big deal. But in a business event, if you miss a purchase, then it's going to be a big deal because you're doing that as, let's say, as a BI as a service, or you're generating invoices, so you have to be very careful that your platform actually does support transactional data. And then, of course, there are a bunch of other types of data ingestion. So we are also working on SDK on open source platforms like Snowflow to basically gather this data on multiple different platforms with our own wrappers. So we have the top layer is the stream processing events, pipelines, which basically you can directly connect you to the output. So what are the outputs? So we have BI dashboards and visualization. We have our real-time products like recommendation systems. We have our insights, which are, for example, the insight that we, almost real-time insights that we give to our sellers, how much they've sold in the last many days, what is their cut out of it, what is the trend, and even some recommendations, and also supporting marketing automation, segmentations, and ad tech. So what's happening inside is, so basically we have a data lake platform, which the data goes into the data lakes, which is an HDFS platform, and then we have our pipelines. So what we do in pipelines, again, is the same concept that Databricks is working on. So we have all these bronze, silver, gold tables, and basically as soon as you go through these pipelines, the data is becoming more and more enriched. So we have our ETL, we have our cleansing the data, enrichment, segmentation, clustering, so it's a pipeline management. We also basically can support any profile that you want to make. So if you want to make a CDP or a user profile, basically you want to see for every user, you want to keep something. So for example, what's the predicted age of this user? What is this? Do they have a kid or not? What is the probability of them purchasing in the next week? What is their churn probability? So you can keep this, and then actually you can keep it up to date. As soon as the data comes in your data ingestion, your pipelines basically get triggered, and they calculate whatever it needs to calculate and update your CDP or user profile. And we also can do the same thing for our products, for our sellers, and also create feature stores. So of course, one of the most important parts is supporting AI. So we have AI applications. So what is an AI application? Basically, it receives some features, it does some prediction. It's the same thing. So we actually use the pipelines to create the input features, and you actually have a feature service which you can actually use discovery to discover what's already there, so you don't redo the features. And then you can use the features. At the same time, you can also do CI/CD on your application, which at this point we are kind of doing a transition there from Jenkins to some other MLOps platforms like MLflow and a few other ones that we're considering. And having a sandbox for data scientists and BI and marketing people to just go and browse the data, discover. So again, another important part of this is being able to monitor all of your platform, both your storage and compute, and having a security so your platform is secure. And of course, the data governance is very important. So who has access to what? So if you have your BI or business analyst going into your platform, who has access to what? And think about it like when you go to your Windows, if you use PC, so you have a file explorer, and then you can actually find data. Some of it could be hidden to you, and some of them could be basically available, and then you can browse, and then whatever you see, then let's say there's a Jupyter notebook or something, you can get it, you can do some basically operations on it, and when you're happy, so you can submit or you can test your code on a staging, and then you can submit your code. So yeah, this is the same thing. What actually makes this very simple is that you just have two clusters which you are managing. One is our compute cluster, which we use Spark, and the other one is the storage cluster, which basically uses HDFS. So we have all of these pipelines. So everything that you see at the top is a pipeline. So there's nothing outside of a pipeline in the platform. So whatever happens is a pipeline. What is a pipeline? Is a combination of some modules, and each module reads data from the platform, from the storage, does some calculation, write it back into the storage. And this is basically whatever pipeline you want, you can implement it like this. Okay, so I'm just gonna quickly go over these and conclude my my talk. So yeah, as I said, it's state of the art. It is modular. It is general purpose. So you can define your own pipeline. It's not specific to any application. It is unified. It uses a unified interface. So let's say all the data goes to the same place. If you know SQL, you can use SQL, and there is a translation in the background to Spark SQL. We also have centralized discovery and governance, which is really important for us. So if we want to make sure that people have access to whatever they need to, the access is controlled, and they have this ability to discover the data. Of course, it's like massive amount of data, so you want to make sure that they can find what they're looking for as soon as they want, and then after they find it, they can define their pipelines, and then they can take it from there. It's also very heavily abstracted, so that was the other purpose of this structure. Is if you don't know Spark, if you don't know whatever tool, you should still be able to use this. Let's say if you're okay, this is a very simplified example, but I use this a lot. If you're running a coffee shop even, and you have your Excel sheet of your sales, you should be able to use this. You should be able to upload your CSV, create your pipeline, and okay, you need to know a bit of SQL, but but other than that, you should be fine. As I said, it supports continuous integration and delivery. It is ACID support, so that is really important for us to make sure that we can actually support transactional data beside the non-transactional data. So that's a big one. Definitely check Delta, which is the open source platform that Databricks is working on. And actually, there are two main companies that are working on cloud-based big data platforms. One is Databricks, the other one is Snowflake, plus a few other ones. The main difference is Databricks has open source a good portion of what they've done. So they're actually going head to head on that. So we have basically tried to be not far from what we're doing right now, so preserving our current infrastructure as much as we can. It is cloud scalable. Right now we are not doing this on cloud, but it is cloud scalable. So the storage and compute in the traditional big data had to be very close. But with this structure, you can actually decouple them as much as possible. You can share the data easily. And so you can support open data, open platform, and research. So, for example, we are the largest generator of data in Iran, and there are a lot of universities in Iran that we actually give out our data, so we can use the same platform to share the data with them. With the whole discovery and governance, they can come and use it. And of course, supports the products and the downstream, as I mentioned. So I think that concludes my talk. And if there is any question, please go ahead. Yes.
Thank you for an interesting presentation. So basically you are replicating most of the technologies that are available only to AWS and Azure customers, and you're kind of building your own. But my question is, I'm more like an ML person than a big data, so I'm more interested in where do you exactly use machine learning? For example, I think you mentioned about operations in logistics.
Yeah. So machine learning, as I said, there are in two different areas. One is in discovery, what we call, so it has search, so we actually have our own search, which is a combination of fetch and ranking, basically the fetch and rank search, which I can go deeper into that if you want, but the fetch part, we use Elasticsearch, and the rank, we use LTR. For recommendation systems, we use machine learning, so we have items that are viewed together, items that are bought together, all these things, plus also finding your interests. So based on your clicks, your views, your add to carts, your purchases, we try to find what are your major interests, both in categories, because we have a categorical tree, and at the same time we are doing keyword generation. So basically you have a content. So for example, you have a category of mobile phones, but you still want to go deeper, so we have like iPhones and let's say whatever, Samsung or whatever. So it is an automatic keyword generation that we're working on. So that's basically on the discovery side, and on discovery side, so we have demand prediction, which we are currently doing like a 30-day demand prediction plus fraud detection. So we have a bunch of different fraud types, of course, that happens, and there's a massive impact on the business plus the operations that you mentioned.
So can you give one more example about operations, like deeper example? Like, my first impression is that if you were trying to optimize logistics, it should be something like linear optimization or something.
Yeah. So actually, operations, to be honest, it is one of the hardest ones for us. First, for a few reasons. First of all, it's super complex. So if you look at the whole like funnel of all these items coming in from all these sellers, they're being stored in like multi warehouses, and they're being picked, sorted, and sent out to the buyers. So because of this super complex, we actually try to isolate. So we have done some simulations on some part of it, but we're trying to isolate some part of it. So for example, we had this project on bin packing. So basically optimizing the size of the package. It wasn't using AI, just an optimization, 3D optimization algorithm. Plus, like, we have a routing platform that we are working on. So basically how to divide between different cars, shipments, and how to dynamically basically change this, and also basically using a we do our own ETA as well. So that's also, so we have been using Google's and Waze's ETA, but right now we are using our own ETA. So some of that, like some factorization there for finding ETAs, and that's basically using that to route.
Thank you. It's actually pretty impressive.
Thanks.
Thank you for presentation. I would like to, can I conclude that you are trying to be not only as Amazon for Iran, but also as Google?
Yes.
Actually.
Well, we don't have any, like, Google is not blocked in Iran, but the rest is kind of, yeah.
Okay, I would like to learn more about your search capabilities and how it works. Do you have something like lemmatization? And maybe we can talk about
Yeah.
much later, but for now.
Yeah, sure. Yeah, actually, search is one of our largest products. We have, I think, like 5 people dedicated working on that now. Because I think around, I don't know if I can disclose it or not. Anyway, it's around like 70% of our revenue comes from search, so it's massive. And we have our own search, as I said, and we are using the whole fetch, and there are, as you know, there are different types of search algorithms. Most of them actually, like, we are not using any like deep or anything, partly because of computation reasons, but we can talk deeper if you want after the presentation. But yeah, so we are also working a bit on basically word-to-vec and all the embeddings on the fetch side as well. But the ranking is LTR. I don't know how much familiar you are with LTR.
Normalize words, Iranian words, to the normal form, to the dictionary form.
Yeah, so we have our own tokenizers and ngram, whatever thing that the team is developing. Some of it we are actually getting outsourcing it to another company that they are actually doing search in Iran. And after, I don't know if you know about this, but the Iranian government cut the internet at some point. I think it was a year or 2 ago, and their use went from like 0 to like something crazy. So they actually got a lot of data there, but they don't have a lot of data. So that's one of our major problems. Is our data is very e-commerce oriented, but we can always, you know, we haven't done this, but we can always go crawl Farsi content.
I think there is space for one question left,
Sure.
so I'm going to invoke moderator privileges.
Yeah, definitely, go for it.
Navid, just can you give us a ballpark picture? The slide that you showed with the sort of the topped up, the layered architecture, a bunch of those things are available as services or product that you mentioned Spark, but for stream processing there is Flink, for logging there is Datadog and others.
Yeah.
And many of them, I mean, some are vendor binded or cloud provider binded, but many of them are more or less agnostic. So
yeah.
Could you give us a ballpark picture of how much of your overall architecture you have to do yourself because you cannot use any of those available tools?
Yeah. So I have to be honest. We don't have many, and we don't have many good data engineers. So we are using a lot of these building blocks. But what we try to do is that we are trying to make this as modular as possible and as little many tools as possible. So, for example, we are using Flink, for example, for our live counter of, like, let's say if we want to see how many people are looking at a page at the product in the last, let's say, 5 seconds or let's say 30 seconds, we use Flink for that, which we actually try to think of moving that to Spark Stream just to make sure that, because we don't have that flexibility of having people knowing all these different tools, and we're actually having our own workshops for data engineers to convert people from data science to data engineering, because there's a real shortage of that. But yeah, I would say maybe 90, like a massive percentage is open source tools, and we try to minimize the number of different tools that we are using. And most of the things that we are doing is integration. We are not like coming up with something like Spark or coming up with something like Flink. We just try to make sure that we are wisely using the tools in a scalable manner, and at the same time we make sure that we balance our resources so they don't have to, so we don't like add tools like every day. So we try to keep the tools that they need to know very minimal.
Thank you very much.
Sure.
Thank you very much for the talk. We are happy to have you.